The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. I'm Kendall Trump with Grain Journal Magazine in Decatur, Illinois. Welcome to Rail Design, on-track insights for your site. This is the 8th in a series of webinars to be presented by GEAPS and Grain Journal Magazine in 2019. Today's webinar is sponsored by M&M Specialty Services. M&M specializes in protecting your people and your products with the best in quality and affordability in personal protection products, grain protectants, fumigants, and services. They are based in Leavenworth, Kansas. Our presenter today is Quin Vincent of VAA LLC. With over 15 years of experience, Quin Vincent leads VAA's rail, infrastructure, and facilities design work. He manages projects including inspection of existing rail facilities and the design of agricultural and industrial bulk material shipping and receiving facilities. Along with rail design, Quin assists in the layout of site utilities, grading, erosion control, and the analysis of vehicle movements to aid in the design of roads, parking lots, and loading docks. You can participate in our Q&A session today by typing questions in the questions box at the right-hand side of your screen at any time during our presentation. We will be addressing your questions during a Q&A session following our presentation. We do have two brief polling questions for you today. First, how many people are viewing at your location? And next, are you a GEAPS member? Thank you all for your participation. As a note, today's webinar is being recorded and it will be posted to our website, grainnet.com, within 24 hours. All registrants will also receive an email containing a link to our webinar recording the day following the presentation. At this time, Quin, can you please do a voice check?
Hello, Kendall.
Thank you so much. And can you also please show us your opening slide? Ladies and gentlemen, here is Quin Vincent.
Thank you, Kendall. Today's talk is going to be an extension of the talk I gave earlier this year at the GEAPS exchange. However, you will not need to be familiar with that talk to get something out of this one. I'll be focused on actual design considerations for industry track. We'll assume for the purposes of this presentation that you have other prerequisites rolling. You know you want to do track, for example. You know why you want to do track. You probably even have some site considerations sorted out, although we will talk a little bit about that. We'll talk interchangeably about greenfield and pre-existing sites. It doesn't really matter for the sake of what I'm going to be talking about too much. It is geared towards facility owners and operators. The idea here is that facility owners and operators probably spending their time owning and operating facilities and not thinking too hard about track design, and they don't do it every day. Although if you're not one of those folks, I imagine there'll be something for you to get out of this too. It'll be just to get you familiar with the terminology and some of the factors that go into design, and won't be a really deep dive into some of the things we do every day when we're designing track. We'll talk briefly about the railroad-driven requirements. Railroads put out publications that talk about what they expect to see. And then we'll get into the geometry and how that affects site constraints and relates to your operational decisions. All of the Class 1 railroads and a number of the smaller railroads publish specifications and guidelines. They cover a broad range of things typically, including the submittal process and other things related to how they expect to see the design. And among those things, they talk about geometry and some of the things related to that. We're going to be focusing in there today. They talk about vertical geometry, curves in the vertical and how the grades affect your track and what your minimums are and maximums are and what they expect to see. And we'll get into that more in depth, but we'll talk about what kind of room they eat up and why you need to allow for them. Talk about horizontal geometry, curvature, and how it relates to other elements of the site, spacing, clearances, that kind of thing. Turnouts and crossovers, how you're going to move from one track to the other, and the kinds of space that those things take up. They have minimum size requirements, that kind of thing. A number of things related to crossings, grade crossings for pedestrians and vehicles, and utility crossings, and structures crossing the track. They have a lot to say about acceptable materials. We'll get a little bit into that as well. And they talk about construction requirements. We won't spend a lot of time on construction requirements per se. There's really not a lot to talk about. The cost implications are fairly straightforward. They're not out of line. You'll be building track per their construction standards, and I guess I would expect any contractor to be familiar with that, so not really a point to deal on, although I would like to point out at this point that they have requirements for flagging. If you're doing work within a certain distance of the main line, and that may vary some depending on location and railroad, they will require a flagger, a railroad person, to protect not only the construction workers, but railroad personnel. So we won't spend a lot of time on the construction side, but that is a concern. And then they'll have other safety-driven concerns that they're going to deal with in their specifications. The railroads are concerned about all of these requirements. As a general rule, they have very little incentive to deviate from them. The requirements will vary from railroad to railroad. And in some places, and they're in place because of how the railroad operates. They're in place because of fundamental engineering principles, and they're in place for safety. When we're starting work on the railroad, whether you have an existing facility or it's brand new, they'll expect you to follow the latest specification. There are a number of reasons for this. Modern locomotives and rail cars are larger than the old ones. They're going to take up more room. And while you have existing assets that might get grandfathered in, anything new will probably need to fall into these requirements. It's probably worth noting that rail car size has changed too. And while your facility operates today with cars of a certain size, they can't guarantee that there won't be larger cars necessarily. So that may come into as a consideration as well. Everything's heavier than it used to be. That also factors in. And safety is probably seen differently. Safety is of paramount concern to the railroads these days, and a lot of what they're doing is going to relate to safety. Quick note before we jump into the geometry though. While the railroad is reluctant to bend or give on a number of these requirements, there may be some room to move on some of them as needed. And typically, cost isn't going to be one of them. It's probably not a winning argument. But assuming they want your business, there may be room for allowances. My best advice is to either ask the railroad what's likely to have some give, or ask an experienced designer what's going to have some give. Number of railroads incentivize larger trains. A lot of what I'm talking about today is assuming that you're upgrading your size or you're building for the large train from the get-go. A lot of the examples are assuming 100, 120, 134 cars, although the same things apply to smaller car movements. So I have the property here. This just happens to be a random piece of property on the railroad. I don't even know if the track would fit here well. But you're probably looking at a piece of property. What will actually fit? If you're going to do a large train, 120 cars in this case, you're going to need to acquire enough land to put that loop track in this case. And in this example here, we have our assets, our other assets on the outside of the loop, or largely on the outside of the loop. It's going to require even more land. As a bit of a pet of mine, a bridge can really take advantage of all of that inside space. You're buying all that land anyway, you might as well put it to work for you, especially if you have the room or the grade change to accommodate a bridge. It surprisingly doesn't take that much to get that in there, and we can take advantage of all that space in the middle of the loop. Although for this conversation, I'm going to spend most of my time at this point on this slide. This is a ladder track configuration. This example happens to be for a 120 car train, but the same issues apply for smaller trains. It's a good example because it captures a number of different concerns. The state road on the left, we will be crossing it. The track does cross it. The railroad will be crossing it when they move in and out of the facility, and the owner in this case will be moving back and forth across that road. But it needs to remain open. It needs to remain open so the public can go about their day-to-day business and get back and forth. But more importantly, you need to keep it open so emergency vehicles can get into the township, can move around. We wouldn't want to block an ambulance. And as a matter of fact, we not only can't block the crossing, we need to stay 250 feet away on either side, 250 feet away from the road edge on either side. So that eats up a little bit of room. We've got the township road in the middle. In this case, we got written permission from the township to close it. That's probably going to be required. The railroad is okay with closing a crossing just about any time, but you're going to need to get permission from the township in this case. And then you'll probably need to block the road off at either end so people don't attempt to turn down that road and get across there. So temporary barricades probably in order. And then on the other end, on the right side, we have a county road. Except for the main line, nothing will be crossing this. We're going to stay away from that, and we're going to have to stay, in this case, with this added track down here, 150 feet away from the crossing with the turnout. There's a few reasons for that. Generally, though, you want to keep it away from that road crossing so it's not a nuisance. We don't want people on the road to get it in their head that they can interfere with that turnout. So we have to keep it far enough back for that. But if you are getting closer, there's other concerns here as well. We don't want a snowplow to hit it. We don't want snow piled up on it. We don't want vehicles that veer off the road to run into it. Just a number of concerns. We'll keep that turnout away on that end. What am I going to do for property here? I think generally we find that in a ladder track situation like this, it would be really nice if we could just negotiate with the railroad, build all our track on railroad property. In this case, that didn't necessarily work out. The expansion on the right side here is all contained within railroad property, but we did need to talk to the adjacent landowners and acquire land to do this extension to the inside ladder there. So property will be a concern, and when we're talking about loops, you're generally going to acquire all the land for the loop. It's probably not an issue, and in fact, if you're going to acquire that much land, you're probably going to keep most of your assets out of the railroad right of way. But if you're trying to find a site that's convenient for ladder tracks, you may be into a number of different landowners, and that should be considered. The next thing we're going to look at here is what we're operating in there. This will relate to some of the geometry and power requirements, but what do I have? Am I dealing with singles, manifest traffic? And it could be one commodity or it could be multiple commodities, but we're talking about anything that the railroad breaks off when they come to your site. They're going to leave a handful of cars and then move on. That'll affect how we're going to handle it, especially if you have 4 different commodities. If you're receiving 25 cars and 4 commodities, we're going to need a lot more room to sort and maneuver that train around. If we're handling a unit train, it's very different. If we have a complete train with 1 commodity on a loop, it's probably pretty straightforward. If we're dropping it, as in the previous example, on a siding, we still need some track for maneuvering, but if we have the other things in place, it'll probably be fairly easy to handle. So some of those things we're going to need to look at once we know the train size is power requirements. The loop, like I said, is easy, pretty straightforward. Typically, you're going to use the railroad locomotives. Not always, but typically. If you've got your own site and you want to be able to move a lot of cars, you'll probably be looking at a locomotive, upper right-hand side there. It comes with its limitations, though. It's limited in its flexibility. You're really not going to get that on and off the track, not in terms of operations. So we'll have to plan for that, but it does allow you to move longer strings of car or cars over more difficult geometry. You have a car mover there on the left side. A lot more flexibility, probably still, depending on the size, can handle a number of cars. Probably not going to be moving 50 car strings with a car mover like that unless you're empty and otherwise optimal conditions, but you do have the ability to move still a fairly large number of cars with the added flexibility that you can get on and off the track. However, it is going to require special conditions to get that on and off the track. They tend to be heavy. You're going to want a proper crossing and proper approaches to that crossing to get the car mover on and off the track. The front end loader in the lower right corner, probably going to move the fewest cars, but offers the greatest deal of flexibility. The crossing requirements to get that thing on and off your track are probably pretty minimal. That loader can clear a lot of things. Although I will point out, if your loader is in this configuration, it just has the knuckle to move the cars and you're moving 1 or 2 cars with it max, you probably don't want to be operating over a turnout. So there are drawbacks to this, not just the number of cars you can move, but the ability to operate through your facility. Once you've figured out the size of your train and the power requirements, now we've got to figure out how we're going to move them around. Again, I'll jump back to that loop track. Probably not a lot to talk about. You're just going to go in a circle. You're either unloading or you're loading, and when you're done, you're done. If you're mixing in other commodities, then we start to talk about how we're going to shuffle the train around. If we're adding additional track to that loop, or we have a siding here like we're looking at in this image, we've got to talk about how we're going to shuffle those back and forth, and the kind of power will affect how many cars we can move at a time, or whether we have the flexibility to get on and off the track. And I'm just going to run through an example here of a sequence of operations. You can see there's subtle changes in the way the cars move back and forth, and this is just a schematic. It's a very easy way to break down the track lengths and segments into something that's easy to understand for car movements. In a lot of cases, the railroad will expect to see something like this as part of their submittal process. It might outright be a set of drawings like this, or it could just be a description, a written description of how you're going to operate. We tend to find that the pictures work better. They also work better for the facility owner as they're trying to figure out how their people are going to operate the track. A fully loaded train there. So let's get into some of the elements of geometry here. As mentioned earlier, the railroad will have specifications that relate to these, and the reasons are for safety, operational considerations, and just sound engineering. What you're seeing here is a plan and profile. it's really distorted in the vertical. It's distorted in the vertical because track is generally pretty flat anyway, and it's hard to see what's going on. But we need to be careful about how we grade out the track within the facility so that it's easier on the power requirements and so that cars don't roll away. I really don't want to park a car and have it move on me. And in fact, the only slope you're seeing on here that a car wouldn't roll away on you is that 0.22. Anything over 0.3, we're starting to worry about where the cars are going to roll and move. Now that 1.5% you see, the 1.5%, probably acceptable in certain areas of your track, but that's only so that you can get in and out of the facility. You're probably not operating on that. The curves, they eat up some room. Here we're showing curves 100 feet long. We're going from a 0.22% to a 0.5%. We have to allow room for that. It may not look like much. In fact, when you're standing there, you might not see it at all. But that does need to be accommodated. And that'll factor into the location of other elements of our track, as we'll talk about later. Horizontal geometry, curvature, spacing, and clearance requirements. The railroad operates bigger and bigger locomotives. If you're receiving a large train, you're going to need to follow those curve guidelines on the top side of this drawing. That 7.5 degree, that 764.49 foot radius curve, or the 9.5. And it depends on the size of that unit and the railroad requirements, but they're going to eat up a lot of room. We're talking about a football field's worth of room here just to get some of those curves in there. It's not small. If you're operating shorter chunks of train, you can get away with the smaller curvature. The 10-degree curve is about as tight as we'll see something deliberately designed. The 16-degree curve is quite a bit smaller than the others, and the only way you're probably dealing with that is if you're already, for example, in a port facility with no room and you're operating through that curve. But if you are operating through one of those curves, you probably know that it's not a good idea. And we're going to really have to beef that track up if we're making improvements to the rest of the facility and you're still going to operate through that curve. So generally expect that in the design, you're going to have those larger curves, and the bigger the train, the bigger the curvature and the more room that they're going to eat up. We also deal with reverse curves. What the image here shows is an S-curve of the track and a string of train cars. I'm showing the string of train cars as straight through there. Obviously, you want to keep those cars on the track. But as you pull a large number of cars through a curve like this, they're going to want to straighten out, just like I'm showing. The railroad and good engineering design will call for a straight piece of track, a tangent piece of track here where these two curves come together. This takes strain off of the train and off of the track structure. And both of those things are expensive. So they're going to eat up room, but they're a necessary part of how this track design comes together. Track spacing. The railroad's going to have a number of requirements for track spacing. We're looking at strictly industry track in this image, but along the mainline track, they'll probably want to leave room because their trains are operating at a higher speed. If something goes bad, they need that train to have the room to not interfere with the other tracks. Your industry tracks and your people are going to need to stay further away from that mainline track. And they also might have requirements for future expansion. Who knows? They might want to put in a double track there. They need you to stay away for that. So expecting to get close to the railroad is probably a non-starter in most cases. As far as your track, though, in the industry track, speed's probably not really a factor, but safety is a factor, and potentially room to grow. Track separations are there so that vehicles and people can operate between the trains without issues. We can't just put these things one right on top of the other. That's not going to work. And on that same note, clearance requirements, they're fairly exacting, fairly rigid. These are actually set by the state, although the railroad will have a set of requirements. Push comes to shove, state or province will govern. Two examples here, we're showing clearance envelopes. The clearance envelope isn't strictly speaking for your locomotive or your rail car. Your rail car, we all know, is not 18 feet wide, but the opening would need to be, in this example, 18 feet wide. The assumption is, as you can see in the CSX image there on the right, that people will be operating on or near your car. You'll need to allow for that. So door openings and structures and so forth will need to accommodate those clearances. Another note is that when you're anywhere near a curve, and I'll talk a little bit about that when we get to turnouts as well, but when you're near a curve, these clearances will widen. In this particular example, for every degree of curvature, you're going to have to add the 1.5 inches to the width, and do that on both sides. That's, again, to make sure the people are safe within there. Turnouts and crossovers. A turnout is simply the structure that allows you to move from one track into another track. A crossover is a pair of turnouts that allow you to move from one track to a parallel track. Turnouts are denoted by a number 11, number 9, number 8. That number is the expression of the angle as a ratio. A quick little side here, if you have existing turnouts and you don't have a label on the turnout, at the very least, we can measure the frog and figure out what the size of the frog is. It's no guarantee that your whole turnout matches the frog, but generally speaking, if you know the number on your frog, you have the same number for your turnout. And so I'll just quickly show you here. You find the frog here where the two rails cross. It's going to look something like this. You measure across this point. Doesn't really matter. Pick a spot that's, say, 2 inches across, and you measure at the 2 inches. Then you have to measure a place where you've increased by 1 inch. Actually, in this example, let's go with 1 inch here and 2 inches here. The distance between those two measurements, where it measures 1 inch and where it measures 2 inch, is the number of your turnout. That's how, more or less, how you come up with that expression. It's not a perfect measurement, but number 8, number 9, 7.5 if you've got an older facility. Turnouts lead up a bit of room. The turnout is defined by this length from the point of switch to the last tie. You'll also need to add the tangent here, but just as an example, a number 9 turnout from the points to the last tie is 107 feet long. Number 11 turnout, 124 feet. You need to consider all of this straight track. You will not be building this in a curve. And then you'll have to meet the curvature requirements off of each end. You know, if it's got a reverse curve, you've got to deal with that. This part of the track, the diverging side of the track, is considered a curve. So when we were looking at the clearance requirements and building openings, you'll need to accommodate for that curvature. Putting a turnout right outside of a building is going to affect that clearance requirement. Also in reverse curves, you got to be careful. Again, we're pulling that train straight through an S curve is going to be complicated. Also, I talked about vertical curves. The track needs to be generally flat, but when we're going from one slope to another slope and a change in slope, we have vertical geometry. None of that can happen within the turnout. Showing a turnout in a flat plane here. I can tip that plane one side to another, or I can have that plane raised on one end, but it all has to be flat. I have to leave room for that entire thing. So in the example of the 124 foot number 11 turnout with the tangent piece on the end, I've got to allow for that whole space to be flat. And then I've got to work in the vertical curves for grade change beyond that. Just need to consider that as we're allowing room for all of these things. Grade crossings. So here specifically on this slide, we're talking about pedestrians and vehicles. Public crossings are dictated by the owner of the road, not the railroad. Typically the DOT will be involved, and they'll have something to say about the type of material used and whether it needs to be signaled, crossbucks, stop sign, so forth. That it will not be something we're dealing with the railroad on, although the railroad will be quick to follow whatever the road owner dictates, and they will be responsible for anything related to the actual signals, is at a public crossing anyway. Inside the facility, you can really choose whatever fits your budget. In the lower left-hand corner there, pretty basic crossing just to make sure vehicles can get back and forth. Well, shoot, you might have a public crossing that looks like that, not very often, but in the facility, just whatever your budget dictates or whatever your needs dictate. If you have, for example, a rail car mover, one of those heavy rail car movers I talked about, you're probably going to want something a little beefier for this. Also in crossings, we're dealing with sight lines. This is again dictated by the state or the DOT or the town, and it affects how close you can store cars. You can see in this particular sight line graphic that there's a main line or a train track crossing the road outright, and they're worried about how far back those will have to be. Now, I said in that previous example that we were holding 250 feet back from the edge of the road. That's not a hard and fast, it's a general rule, but if there's structures already obstructing that view of the crossing, other things will come into play and you might get closer. The spur track or the dead end track there on the right-hand side, that's where this gets interesting. You're going to have to hold back far enough so that a car stopped there can see trains approaching. We want to make sure that this driver can tell if there's a fast approaching train, especially if there's no flashing signals. If it's just a stop sign, you're going to have to give them the visibility to judge the safety of that crossing. Utilities. We could spend a whole presentation on utilities. Many railroads have an entire specification devoted just to utility crossings. It can be a little contentious with the railroad sometimes. Their relationships aren't necessarily always rosy with the gas company or the electric company or the fiber optic company. And so if you're dealing with public utilities or private utilities, there will be a lot of requirements that relate to this. I'm not going to dive into that. Just be aware that that can take time and that those guidelines will have to be followed. Structures. Here's a fairly simple example of a facility here. We've got some fall protection and a spout and a gangway encroaching on the clearance envelope. All of those things will need to be capable of swinging out of the way or being permanently out of the way of the envelope. In this particular case, they actually were a little too close in some ways, and so they had to post impaired clearances. Not ideal. Certainly not as safe as it might be for your people. A note though, when you're crossing a main line, there's going to be more related to those clearance requirements. This is an industry track and it's their own track and they've got that, and the railroad still cares. They want this thing to be safe, especially if their assets are moving through there. But if your facility spans across a main line, you're going to have a whole other set of considerations to look at, and the structures will have to meet certain strength requirements. They're going to have to probably be further away. If you have any towers or other structures that are supporting the crossing, they will either have to be reinforced or kept very far away from the track. So some things to consider with structures as well. Not just a building, but any structure related to the track. Let's get into materials a little bit here. The railroad will have something to say about all of these things. Rail size. They'll have minimum requirements. They'll have minimum expectations about relay rail or used rail. And they'll have minimum size requirements. And this again relates to heavier locomotives, heavier train cars. It does not relate to your maintenance, however. You might want to consider, as you're looking at these things, maybe upsizing or having a conversation with your team about the cost versus the maintenance or the ongoing costs related to this item, rail in particular. Rail being at the top is probably one of the easier things to swap out though. So if you go with the minimum requirements, changing later is less problematic. Ties. You're seeing steel and wood ties here, particularly wood ties with anti-split devices. The railroad will have requirements around ties as well. Again, they're minimum requirements. And in fact, in some cases, you can get exceptions for even lower than the minimum. It's really down to you and maintenance. Again, the railroad probably doesn't care about your maintenance. They really care about how it looks right now and whether or not they're going to put their assets in your track. If at some point your track degrades, they might cease to serve you until you get it fixed. So again, considering the maintenance required with it and some of the installation, some of the other factors that come in with these materials, the steel ties, for example, might save you on ballast, but will require closer observation when it comes to install. So just a few things to look at there. They'll certainly care about ballast. And as we get deeper into this road section, I guess I care more about it too. Ballast is going to be very difficult to change out if you get it wrong. It's probably one of the single most expensive elements of the track structure. Probably spending a lot of money on facility upgrades anyway. The single thing that could break the bank here would be the ballast. But I would encourage you not to skimp here. Good ballast will be angular. It'll be made out of a hard material, and it'll be sized such that it doesn't trap a lot of fine material. The round stuff on the right-hand side is landscape rock. If you see that on your site, that is not ballast. Don't accept that. It might be a lot cheaper, but it's cheaper for a reason. A railroad will have minimums regarding size. You might want to consider upsizing the ballast. It'll serve you better if you do. And again, the deeper into the section, the tougher it is to change these things out. The railroad specifications do get into drainage and site prep a little bit, but not as much as one would think, or as designer coming from the design side, not as much as they probably ought to. The single biggest factor in the quality of your rail over time is how well this subgrade is prepped, drained, and set up to hold the rail structure. You're seeing an earthwork happening for a loop track here with subballast on top. The subballast is the material, as it might suggest, right under the ballast. Think of that when you're planning for your track as a quality gravel road material. It's typically not going to be as thick as an actual gravel road might be. The track structure does a pretty good job of spreading the load out, so it doesn't have to stand up to truck traffic per se, but it does need to be firm. It needs to shed water, needs to set up nice. It'll have enough fines to bind together. It'll have enough angular material to lock together. The picture in the lower right there, pretty good take at everything we just talked about. They got the subballast at the bottom, a good quality ballast above that, ties within spec above that, and a good quality rail on top of that to boot. The deeper you go into the track structure, the harder it is to see anything, but the more expensive it is to fix. So if I had my druthers, people would spend the bulk of their time and energy as it relates to track, the deeper you go into the track structure. The higher up we come, the easier it is to replace and fix. There'll be some specifications for some other things as well: rail anchors, joint bars, bolts, spikes, tie plates, so forth. These are typically not deal breakers. I would expect that your track contractor would follow the specification and do at least the minimum in getting the right materials in there, but it's typically not going to be a major cost item. I'm not going to spend a lot of time on it here. The last elements of the track structure are related to safety here. I'm showing some bumpers and some derails. Derails are put in place to generally protect railroad assets or other parts of your facility, if in some cases. They're placed there so that when you're operating the train, cars don't roll out onto the main line, foul up the main line, cause a collision, or tip over and land on railroad property. They're made to direct rolling cars away from the railroad and onto your property. That doesn't mean they're protecting your rail cars. Doesn't mean it won't be expensive if you go through that derail. And bumpers too. Bumpers, you don't want to run off the end of your track. I'm not showing an earthen bumper. I'm showing bumping posts here. Those aren't meant to stop your train on a daily basis. They're meant to stop it in the case that something rolls away. You'll need to allow room for these things as you're designing your track. So this morning we talked a little bit about some of the elements of the track. I assure you that as a designer of track, I could get way deeper into these individual elements. There's a lot of factors that come into play as we try to get all these things to marry up. We talked about a little bit about why the railroad might specify them, although we didn't talk about railroad process. We did mention that if you need to, you can get exceptions. I wanted to show this photo last because it kind of bends a lot of the rules. We have a curve coming into a building, not a good idea. We have a grade change coming into the building. You can see the track is standing on stilts, and those are all in varying heights. The railroad still wanted to serve this facility, and they were limited on room. But these things took a lot of time to get approved, and were not cheap, but they were done. I would generally caution you to not find yourself in this kind of position. So I thank you, folks. If you have any questions, I think Kendall will moderate that.
Thank you so much for a great presentation today, Quin. That does conclude the presentation portion of today's event. We will now begin our Q&A session. And if you have not yet submitted your questions, please do so at this time. Okay, Quin, our first question today. Is there a typical percentage of track that you add for maneuvering cars around?
There is not a typical percentage that I would apply. It really depends, of course, on the number of cars you're going to need to handle. Multiple commodities will be different than a single commodity. But as an example, if you're dealing with a single commodity unit train, 120 cars, for example, in a ladder track configuration, long straight track, you probably need the length of the train plus half that length in additional track. Probably a pretty safe bet. In a loop track, you don't need really any additional track. The only additional you'll need is to make your connections and avoid your clearance issues.
Okay, our next question. What are the benefits of metal ties versus wood?
The real benefit is that metal ties will save money on ballast. There's probably a break point. It's not a guaranteed solution. If your ballast isn't overly expensive, the cost of the tie might not outweigh the cost of the ballast. But in general, the steel tie will require less ballast. And so in a lot of situations where the ballast is expensive, the steel tie does make sense. One caveat there is just make sure they get installed correctly. If you do, they should give you long life.
Okay, on pre-existing track where a loop track could be added, what are options for overpasses or underpasses to access, and the pros and cons and price comparisons?
Well, there's a lot there. Certainly it's going to depend on your local conditions for topography. If you already have a hill and you're going to cut a loop track through a hill, you might have a built-in opportunity to put an overpass, something to drive over the track. Or if you're going to be spanning a gap, you might have an opportunity to drive vehicles under your track. Cost is very local, of course. I showed a couple of examples. I've been involved in more examples. They've ranged in price in the Midwest generally, and some of these factor in earthwork, some of them don't, but from $850,000 to $1.5 million just to get that bridge in. But it could be worth it if you're going to optimize the inside of that loop. It's worth it. And I will point out too that using the inside of the loop without it could be a real problem, particularly if you have an emergency, an accident, you need to get an ambulance in there or something. So access to the inside of that loop might not just be about maximizing your property, it's also safety.
Okay, our next question. Would you get your railroad service provider involved in the planning right from the beginning to get their input?
If you're looking to be rail served, you're going to want that input. The railroad has their particular pets in this design process, and they may not be yours. That doesn't mean they're bad people. They just don't have your interests in mind per se. They're trying to get your business and get it built to their specification. But if you're trying to optimize this facility for how you're going to operate and be served, then I would recommend it. And it doesn't really take much up front. Your rail service provider can do a lot for a little using just aerial photography and some sketches about what you expect for your facility.
Okay, next. Can we have vertical curves on horizontal curves in loop tracks?
It's generally avoided. You probably in a loop track have the room to avoid it. I would say as a general rule, we're not going to do that.
Okay, next. At an intersection, how close can my car storage be to the road?
So we talked about those site clearance lines. The railroads or the FRA or other agencies will talk about a 250-foot clear on either side of the road, probably a good rule of thumb. And in open countryside with not a lot of control on the crossing, that's probably what you're into. But if you're in town and there's already a warehouse that's right up to the road, you're going to need to keep those cars at least out of the site triangle from that road to the main line. So it will vary quite a bit. It'll have to be analyzed. I've seen people get their cars stored a lot closer than that 250 feet, though, if the conditions are just so.
Okay, next. You talk about assumed rail car sizes, and I'm pretty sure my cars are smaller than that. Why can't I assume a smaller size?
Well, I guess that's generally at your risk as an owner. The railroad is going to want to know that they can land their train, and they're going to have a certain car size related to how that train will be spotted into your tracks or landed into your tracks. After that, the kind of track space you need to maneuver the train is really up to you. Although, if you're assuming you, for example, have 50-foot cars and they start delivering a bunch of 55-foot cars, could be real problematic real quick. So you might accept some level of risk related to car size, but as car sizes change, make sure you're accommodating that.
Okay, and this will be our last question for today. How long will it take to complete a railroad-approved site design?
So the actual design is probably not your critical path item on the schedule. It's probably going to be the railroad approval process and the time it takes the railroad to evaluate the design, move it through all the concerned parties on their end and get the sign off. But the actual design, just to get something schematic to the railroad, can happen in a week or less, if depending on the complexity, or it could take up to a month. A fully vetted design, I would expect at least a couple months, maybe 3. Depends on how much the railroad wants your business, though. If they're not keen on serving you, that could take a lot longer.
Okay, that is all that we have for our Q&A session today. I want to thank everyone for their participation. If your question was not answered, it will be sent forward to our presenter. And that is all that we have for today. I want to thank our sponsor, M&M Specialty Services, for their support in bringing you today's webinar. And I also want to thank GEAPS and our presenter, Quin Vincent from VAA LLC, for joining us today. As a reminder, this webinar has been recorded and it will be available for viewing on grainnet.com within 24 hours. All registrants will also receive an email containing a link to this recording. Our next webinar with GEAPS will be held on Wednesday, September 18th at 10 a.m. Central Time. Carly Crouch of Purdue Learning University will be discussing Understanding and Managing Generations. I want to thank you all for attending today, and I wish you all a great day.